Hello? Yes, this is Justin. I got the job? Yes! I mean, wow, thank you so much for the opportunity. Yes, I'll be there Monday at 8 for training. Goodbye. I got the job! I got the job! This is my dream summer job, working at the Circleville Candy Company. They make the best sweet treats and ship them around the world, and I get to help! I can't wait for my first day of work. They said it's gonna be training. I'll learn everything I need to succeed. Woo! That was a long first day. I learned so much, but I have a lot to study too. Mathematicians, can you help me review what I learned today to impress my boss? Training today involved a lot of new terms for me, so let's go over them. The first part of the manual is titled 2D and 3D shapes, but I didn't need 3D glasses for training. On the left are two-dimensional shapes, and the shapes on the right are three-dimensional. What do you notice? Write down the differences between 2D and 3D shapes. Two-dimensional, or 2D shapes, are flat shapes that can't be picked up. Squares, circles, and triangles are some additional examples. Three-dimensional, or 3D shapes, are solid. Because they're 3D, you can pick them up like a sphere, cylinder, or pyramid. My manager suggested a quick experiment to show the difference between 2D and 3D. Here, I'll show you. I need a piece of paper, a pen, and a round ball. If you want to join me, grab those supplies. First, on the paper, draw a circle. Now, try to lift the circle off the paper. Well, that's just silly. You can't. It's 2D. But now, pick up the ball. You can hold it because it's a sphere, which is 3D. Ooh. So 2D shapes can't be picked up, but 3D shapes can. Here's another example. The manual gets a bit more technical, so I want you to see this page. We're presented with a bunch of shapes, and we need to decide, are they 2D or 3D? Label each shape accordingly. Starting from the top left, we have a rectangle. That's 2D. The oval is also 2D. Next is a pyramid. That's 3D. And last in this row is a diamond, which is 2D. The second row starts with a cube, definitely 3D. This is a cylinder, also 3D. Then we have a circle, which is 2D. And the last one is a parallelogram, a two-dimensional shape. My manager said I need to learn about 2D and 3D shapes in order to understand the instructions for making candy. Here's an example from the training manual for chocolate candy. Chocolate candy instructions. 1. Select the cylinder molds. 2. Fill the molds with milk chocolate. And 3. Decorate the candies with white chocolate circles and squares. Here's the trick. We need to identify which parts are 2D and which parts are 3D. Underline the shapes in the instructions and label them as 2D or 3D. The first shape we come across is a cylinder, which is 3D because it's solid. And in the last step, there are two shapes, circles and squares, both of which are 2D. So we're going to form the chocolate candies in the cylinder molds, since we can pick those up, and then we'll use white chocolate to draw the 2D shapes onto the chocolates. Here's the last example in the manual. Caramel candy instructions. 1. Draw rectangles onto wax paper. 2. Cut out paper wrappers. 3. Pour the caramel into cube molds. And 4. Wrap each caramel in the wax paper. Same as before. Underline the shapes in the instructions and label them as 2D or 3D. The rectangles in step 1 are drawn on, so they're 2D. But the cube molds in step 3 are 3D. You can pick them up and fill them with delicious caramel. At the Circleville Candy Company, they specialize in, well, circular candies. The circle is a 2D shape, and it's made up of a few specific parts. The first part of a circle is easy, the center. The center is the exact middle of a circle. Where would it be here? Yes, point C. Other points are on the edge, not the middle. Also, the center must be exactly the middle, not just approximately. The next circle part is the radius. The manual has these pictures to show what a radius looks like. How would you describe a radius? Write down your idea in your notes now. A radius is the distance from the center to any point on the edge of the circle. If I go from point C to point R and draw a line, that's the radius of the circle. Are there other radii, that's the plural of radius, you can draw in this circle? Draw 2 more radii on the circle. Yes, going from C to D draws a radius, and C to M makes one more. If you go from the center to any point on the edge of the circle, you've drawn a radius. Oh, now I see. When you use radii, you get perfectly even slices of cake or pie. Our next term is diameter. The manual shows these pictures as examples. What's the diameter of a circle in your own words? Write down your thoughts in your notes. The manual says a diameter is the distance across the circle passing through the center. Diameters divide the circle into halves. Here are 3 more circles, A, B, and C. Circle A's radius is 4 inches, and the diameter is 8 inches. Circle B's radius is 10 inches, and the diameter is 20 inches. And Circle C's radius is 33 inches, and the diameter is 66 inches. What pattern do you notice? How is the radius related to the diameter? Jot down your idea now. So, what did you notice? Well, in Circle A, 4 times 2 is 8. In Circle B, 10 times 2 is 20. And in Circle C, 33 times 2 is 66. So the diameter is always double the radius. Why is that? Draw this with me in your notes to prove that the diameter is always double the radius. First, draw a radius going from the center, Q, to point N at the top. Now, draw another radius from Q down to the point at the bottom, S. What is this line called? A diameter. It goes through the center, across the whole circle. That means that the radius plus the radius equals the diameter. So to find the diameter, if you're given the radius, just do 2 times the radius. Using variables, we would say 2r equals d. Let's break down another example. In Circle E, the radius is 5 millimeters. What's the diameter? See if you could figure it out on your own first. There are 2 ways you can solve this. First, add the radius to itself. 5 plus 5 equals 10, so the diameter is 10 millimeters. Or you can multiply. 2 times the radius equals the diameter, so 2 times 5 equals 10 millimeters. Use whichever method you prefer. Now, example 5. In Circle G, the diameter is 14 inches. What's the radius? Oh, this is different. We're working backward to go from the diameter to the radius. If 2 times the radius equals the diameter, how could we find the radius when we're given the diameter? Yeah, we could take the diameter divided by 2 to find the radius. Pause the video here to try example 5. 14 divided by 2 is 7, so the radius of circle G is 7 inches. The manual has 2 candy-related examples. Help me out here. First, our caramel delights are circular hard candies. Their radius is 1 centimeter. What's the diameter of each candy? And second, circular chocolate coins have a diameter of 0.6 inches. What's the radius of a chocolate coin? Let's solve both of these on our own, then compare our answers. For the caramel delights, I doubled the radius. So I calculated 2 times 1 and got 2 centimeters for the diameter. For the chocolate coins, I need to do the opposite since I'm starting with the diameter. I'll do 0.6 divided by 2, which is 0.3 inches for the radius. The last term in the manual is circumference. The circumference is the circle's perimeter. You already know what a perimeter is, so trace the circumference of this circle. The circumference circles around the outside, so you should have traced the whole edge of the circle, like I did in red. Now that we know all the parts of a circle, let's match them up. The circles on the left have a blue highlighted part. Match the pictures with the terms on the right. Circle A has the outside edge in blue. That's number 3, circumference. Circle B has a blue line going from the center to the outside edge. That's radius, number 2. Circle C shows a point in the exact middle, so number 4, center. And finally, circle D has a line dividing the circle into 2 through the center, matching with number 1, diameter. I'm gonna impress my managers so much tomorrow with all this studying I did. Maybe I'll even get to start making some candy of my own. Oh, yum. I'll see you again soon, but in the meantime, finish your notes and complete the first 2 practice levels. Until next time, keep questioning, keep calculating, and remember, the world's sweeter with geometry in it. See you next time. Hey.